Hello, everybody. How are you all? I hope everybody is doing well. So, this is me, and I welcome you in the lecture number third of electricity. So, let's begin this class. Okay. So, yet we have seen what is potential difference, and we also saw what is electric current. Okay. Now, we are going to discuss a very important topic, and that is Ohm's law. That is what Ohm's law. It is very important. It is, you can say, it is the spirit of this chapter. Without this chapter is nothing because this law will be used very frequently in numericals. In numericals, it will also come in your higher classes. And without this, you won't be able to understand the later concepts, the concepts which we are going to discuss later. So let's talk about what does this law states. So basically, our voltage is dependent to the current, or you can say that our current is dependent to the voltage. So basically, let's suppose what is voltage. So this is, let's suppose, a jar, and I have filled this jar till this level. And let's suppose this is another jar, and I had filled this jar. Let me draw it of the same size. So this is another jar, and this is filled up till this level. So basically, here you can see that there is some difference between the levels of waters in the jar. Okay, so if I connect these two jars by the help of a wire, let's suppose I connect these jars by the help of a wire. Okay, so let me draw it again. So what will happen? The water will start to flow in this direction because as you can see, the level here is higher and here the level is lower. So that's why the water will be flowing towards the lower level from the higher level. So the same thing happens with the charges also. Let's suppose this is a metal and it has lots of negative charges like this. And let's suppose this is another metal, and here the density of charges is very less. So if I connect these two wires, or if I connect these two metals by the help of a wire, then what do you think? Where would the charges flow? So basically, the charges would flow towards this lower level of density from the higher level of density. Okay, and it will keep moving until the density of the charges or the level of charges is same in the both materials or in the both metals, just like water. Now, what if I take another situation? Let's suppose this is also a wire. Let's suppose this is also, let me erase it. Okay, so this is also a jar and this is another jar. Now what if the level of the water in both the jar is same? Now if I connect it, then the water will not be flowing. Why? Because the level of the water is same in both the jars. So that's why water will not flow. The same thing will happen in the case of metal also. If the charges is same in both the metals, let's suppose the charges are same in both the metals. Now if I connect these metals, then the charge will not be flowing either side. Why? Because the level of charge is same. So In the electricity, the level of charge, you can also understand the level of charge as potential difference. The level of charge is potential difference. Okay. So in this case, there is a potential difference. Why? Because this is at higher level, this is at lower level. So that's why a potential difference, a difference of levels is can be seen here. So that's why the water was flowing. But in this case, the potential difference, or you can say the difference between the levels of water is zero. So that's why no charge, no water is flowing. Now, in this case, you can say that the levels, you can see that there is some difference between the levels. So you can say there is a potential difference. And due to those potential difference, a charges is flowing towards the higher level to the lower level. But in this case, the potential difference is zero because in both sides the charges are in the same quantity. So that's why there is potential difference, there is no potential difference, and the current will not be flowing. So I hope guys you might understand what is potential difference. Now let me, okay. So now this current depends on the potential difference. Why? Because the more the potential difference, the more the potential difference, the higher the current will flow in. Okay. Let's suppose if in this condition, if I increase the water level, then the water will be flowing at higher rate. The water will be flowing very fast. And in this case also, if I increase the amount of charges, then also the charges will be flowing very fast. And the rate of the flow of the charges is known as current. So it simply means that current will be higher. So that's why the voltage is proportional to the current. Now, if you remove this proportionality sign, then you will have to apply a constant, or you can say you will have to add a constant instead of this place. Okay, so this constant is known as R, and this is the resistance of the circuit. This is the resistance of the circuit. Okay, so once again, let's talk about resistance. What we have seen that our potential difference, or you can say our current, is directly proportional or dependent to this potential difference. If I remove this proportionality sign, then I will have to add a constant, and this constant is known as resistance. Okay, so now here we have seen two conclusions. First one is that current depends on V. V means potential difference. And it also depends, current also depends on R. And R means resistance. So I hope guys you got my point. Now let's move on to the next slide. So here in this slide, we will discuss more about resistance. Now, let me tell you conceptually, then what is this resistance? So basically, you can see that this is a wire. This is a wire. And this is, you can see that this is a metallic wire. This is a metallic wire. So when you apply, or you can say when you add or connect it from a battery, then what will happen? The electrons here will be flowing towards the positive terminal of the battery, like this. Now, on the way, when they were moving, towards the positive terminal, on the way they will have to collide with particles, because there are lots of particles on his way. So that's why they will collide with these particles, and because of this collision, the current, or you can say the rate of flowing of electrons will be decreased. Okay, so that's why this collision, due to this collision, there is a loss of current. So this is known as resistance. This is the resistance, because it is resisting, or you can say this is the resistance, is the ability of this wire to resist the flow of electron, or to resist the current. Okay, so I hope guys you might understand what is the meaning of resistance. Now here the same thing is written which we have seen also on the previous slide, that potential difference and currents are proportional, like current dependent on the potential difference. The higher the potential difference, the higher the current flowing in the circuit. And if you remove the proportionality sign, then you have to add this equal to sign and a constant, and this constant is resistance R. Okay, so this is nothing but the statement of Ohm's law. This is the statement of Ohm's law, that the current depends on the potential difference as well as resistance. It also depends on the resistance, because let's suppose this is a battery and this is let's suppose a resistance. You connected a resistance here. So this is the symbol of resistance. It is like a speed breaker, because it is decreasing the speed of current. Okay, this is like a speed breaker, up down. Okay, so symbol of resistance, and this is what? This is your battery. Now guys, what happens? The value of this resistance, let's suppose 10 ohm. Ohm is the unit of resistance. This is the unit of resistance. So basically there is 10 ohm resistance, and let's suppose the potential difference of this battery is 20 volt. Okay, the potential difference or the voltage of the battery is constant, and the resistance is constant. So now the current will depend on these two quantities. How? That by this formula we know that potential difference is equals to current multiplied by resistance. So if I multiply it here, then it will go in divide, and the value of current will be V upon R. So here the current is I is equals to 20 upon 10. So it means 2 ampere. Ampere is the unit of current. So now guys, if I increase this value, if I increase this resistance 20, then what will happen? The current will be 20, means potential difference, upon again 20, which is resistance. So now the current is 1 ampere. So it simply means that a current depends on the resistance inversely. It means the current is inversely proportional to the resistance. It means the higher the resistance, the lower the current. So I hope guys you get this point, and you also understand the relationship between the voltage and the current and the resistance. Now let's move on to the next slide. So here in this slide, I try to make you understand by the help of this diagram. So let's suppose this is a wire. Okay, this is a wire, and this wire is connected to a battery. Let's suppose this is a battery. So basically, what will this battery do? This battery will force the charges, or you can say will push the charges in this circuit, and it will make it flow in the circuit. Okay, so this battery is pushing the charges, but This is our resistance. This guy standing here is our resistance, and this is your battery. Or you can say, what will battery do? Battery will apply potential difference. So this is V. So V is actually pushing the current. This is A ampere. And what is ampere? Ampere is the unit of current. So this V is pushing the current, but this ohm or resistance is opposing it. It is opposing it. You can see if it tight this rope, then it is difficult to move for the charges. So that's why you can say that potential helps current to flow in the circuit, but resistance resists current to flow in the circuit. That's why it gets its name resistance. So I hope guys, by this diagram you can easily understand what is the relation between current, voltage and resistance. Now let's talk about the definition of the resistance. So it is the property of conductor to resist the flow of charge through it. So basically we know or we understand what is resistance actually. But here, if you are asked that what is the definition of resistance, then how would you define? How would you write it? So you have to write down this definition, that resistance is the property of a conductor to resist the flow of charges. It is a property of a conductor to resist the flow of charges through it. Okay. Now the SI unit of resistance is ohm. If I want to say that there is two resistance, so it doesn't have any meaning. I will have to write 2 ohm. This is the symbol of ohm. It is a Greek word. It is a Greek word. Okay, so 2 and ohm. You have to add ohm. So now I will understand that you are talking about resistance. So guys, be careful before writing units. Writing units is very, very important. If you are not writing units, then it doesn't have any value and your marks will be cut. So let's go on the next slide. So here we are. Now we have to write down what is the definition of 1 ohm. These things, these definitions are frequently asked in examinations, because the definition of resistance, the definition of current, definition of potentials is very normal thing to us. Okay, because every student who is in class 10 know these things. So what they ask these definition of 1 ampere, okay, which I told you in the previous lecture, or definition of 1 ohm. It is very important. So let's talk about definition of 1 ohm. So if, let me write this, V upon I. Okay, I can write this formula. Now you might wonder, so how can you do this? You don't tell us how this formula comes. So let me tell you guys, we know that V is equals to IR. So I didn't do something rocket science. I simply cross multiply this I here. So it will go in divide, and the formula of resistance will be V upon I. Okay. So basically, by this formula, I will figure out the definition. So how would I do that? If 1 ampere of current flows in a circuit, when 1 volt potential is connected in circuit, then the resistance is 1 ohm. Let's suppose this is a 1 ohm. Let's suppose this is a resistance. We don't know its value. Okay, but we know that 1 ampere current is flowing in this circuit by connecting 1 volt potential. 1 volt potential, and this is 1 ampere current. Okay, so if 1 ampere current is flowing in this circuit, when I connect 1 volt potential, then what will be the value of resistance? resistance will be V upon I. V is 1 and current is also 1. So the resistance is 1 ohm. Okay, so this is how we get this definition, that if 1 ampere of current flows in a conductor when volt potential is connected in circuit, then the resistance is 1 ohm. So I hope guys you get my point. Now let's move on to the next slide. Let's try to understand some other things or some other concepts related to this. Let me change. Okay. So how we show resistance in circuit? How we show resistance in circuit? So as we already know that this is the circuit symbol of resistance. This is like a speed breaker. Okay, what a speed breaker do? A speed breaker basically decreases a speed. Nowadays, a speed breaker is more dangerous. Okay, in India it is like this. Okay, so this can also create lots of other issues. So, okay, let's not discuss these things here. So basically, this symbol of resistance is like a speed breaker. So why it is like a speed breaker? Because it decreases the speed of current. Now how it looks like? So this is how it looks like. This is a resistance. And you can see that there are some colors. There are some strips of different colors. So by the help of these strips, we calculate the value of this resistance. Okay, and this is not the part of your syllabus, so I will not be discussing that how can we do that. You just need to remember that this is an image of a resistance. An actual resistance looks like this, and by the help of these strips, by the help of color of these strips, we can calculate the value of resistance. So now guys, let's move on to the next slide. Okay, so here we are. So basically, this is a variable resistance. This is a variable resistance and it is also known as rheostat. Rheostat. So now you might think that how can it be a variable resistance? So basically, let's suppose this is a circuit and this is your normal resistance, which we've seen or which we saw in the previous slide. So this has a fixed value of 3 ohm, let's suppose, then its value will not be changing. It will remain 3 ohm. But in the case of rheostat, what can we do? We can simply change the value by moving this handle. Okay, by moving this handle, you can change the value of the resistance. So if you want to connect 6 ohm resistance, then here you have to add the resistance manually. But if had it been the rheostat, then what would you have done? You would be simply changing the value of the resistance by adjusting this handle. So I hope guys you get my point. Now let's move ahead. Okay, other thing also we forget to learn, and that is circuit symbol. It is the circuit symbol of variable resistance. The circuit symbol of normal resistance is this, but when you add an arrow like this, then it will become a symbol of rheostat or a circuit symbol of variable resistance. Okay, I hope you got it. I hope you are enjoying this lecture. This is very, very important and very interesting as well. You might not be feeling bored while understanding this. Now, guys, this is ohm meter. And what is ohm meter? It is just like a meter, just like voltmeter. In the case of a meter, okay, what we was doing, okay, let me write down the right spelling of a meter, and that is ammeter. Okay, so in the case of ammeter, we used to measure the value of current. Value of current. Okay, in the case of voltmeter, we used to measure the value of voltage. But in the case of ohm meter, we will calculate the value of what? Resistance. Okay, I hope guys you get it. Now let's move on to the next slide and let's try to understand how a resistance is dependent. Okay, how a resistance is dependent. So basically, this is a resistance of a conductor. This is what? A resistance of a conductor. So if a wire is long, let's suppose this is a long wire. So what will happen? It has its resistance is higher if I compare it to the resistance of a short wire. Why? Because here there would be more collisions because the wire, the length of the wire is high. So that's why lots of particles will be colliding from electrons. Okay, because you can see that the wire is long. But in the case of short wire, less particle will be colliding through the electron. So that's why the resistance of the short wire is lesser and the resistance of the thick wire is higher. Okay, now let's talk about, the resistance of the short wire is lesser and resistance of the long wire is higher. Now let's about the thick wire and the thin wire. So in this case, this is a thick wire. So in the case of thick wire, you can see that there is more space for the electrons to flow because the wire is thick. But in the case of thin wire, there is very less space to electron to move. So that's why in this case, the resistance is higher. But in this case, in the case of thick wire, the resistance is lower. So by this, we can figure out a formula, and that is, let's suppose resistance here is directly proportional to the length. As you can see, the long wire has higher resistance and the short wire has lower resistance. And the other relation we can figure out, and that is, it is inversely proportional. It is inversely proportional to the area. Here, if the area is higher, then the resistance will be lower, like the thick wire. But if the wire is thin, so it means the area is lower. If the area is lower, then the resistance is higher. So I hope guys you got and you understand these concepts related to the resistance, and you might know how a resistance is dependent on the length and the area. So now guys, it is time to end this lecture and I will see you later. I hope you enjoy this. So bye bye.